Welcome to this UASMaster video tutorial setting up the training data for the aerial case. We are using in this video tutorial the version 9.0 and we'll run it with the training data which you can download from our download page. In case you have older projects already run with version 8, you can use here the open function and convert the project into a version 9.0. In this video we will set up the project from the beginning and we start to run the area mapping project type for the training data. So we start and we get at the beginning a message telling us that we are at the present using a local coordinate system. We will run this in the UTM 31 North system, so we will change the coordinate system here and select here in the projected systems tab the EPSG code 32631, and this will then directly take us to the WGS 84 UTM zone 31 North, which we can choose and say OK. We can say OK and we will continue to import our camera. We will select here with double click camera sensors. And we can now add here a new camera. The camera is the UX5, so we can select already a preset camera entry, which you can choose here from this button. And we can select the maker, which is Trimble, and the model is the UX5. We can say OK, and we will enter here a name for the camera, using it here in our training data. We can say OK and continue to import our photos. We import here from a subdirectory or from a directory and select from our TrainingData UAS the images folder. We will go through the wizard and select next and go continue until we go to the input settings. Here we can assign the already existing camera from the project, which is the demo camera, and we will enter as mean terrain height 85 meters for this project. Then we can finish this part and say OK for the frame photos. Next we want to import our Gnss data, so we double click Gnss IMU, we import a file and we again go to our input folder from our downloaded training data. Here we can find the CSV file with our GNSS data. We open it up and we will start here from line number 2. We see that the data is in latitude, longitude, so in geographic coordinates. This is very important during our import to choose the correct coordinate system where the data comes from. Additionally, here we already have grouping separators separating the different strips. If you don't have separators, then of course don't use it, but in our demo data it makes it easier for the strip definition, as we will do it. Then we look at the separation between the entries, which is comma, so we select as the limiter the comma, and then we continue to assign the columns. So the first column is the ID, and as mentioned, this is now latitude, then the longitude and the height, and as this is aeronautical data, it's yaw, pitch, roll, so the first column here is yaw, second is pitch, and the third one is the roll. The ID in the GNSS includes the complete file name and the extension, so we don't want to import as an ID the .jpeg, so we will deploy and only use the first 8 digits, and therefore we will only import the DSC and the number without the dot and the extension. This is fine now for us as entry, and as mentioned, this is now aeronautical rotation in the sequence roll, pitch, yaw, and then we continue, and the data is coming from the geographic system. It's not already in the projected, So here we select where the data comes from, and therefore we choose here now the geographic coordinate system, WGS 84. Next we can choose if we want to initialize the data, which we will do from the GNSS data, and if we want to generate the strips, which we will also do. We will check the initialization by going later on again back to the frames here in this video. The strips have been automatically extracted, and we can now finish the part. The GNSS data is by default given a standard deviation which applies around 10 meters in position and 1 millidegree in IMU. For our data this is fine. If you have high precision data, of course you would need to change the standard deviation here. Then we want to check the initialization. That means we imported GNSS and the data was automatically applied to the photos. So therefore we should now see for each photo an east, north and height value existing for our photos, which is the case here. Finally we import our control points. Here again we select from the input folder our GCP file, UASMaster ground control points, and here we start from line 7 to import our ground control points. The data is already in UTM-31 North, therefore we can directly import the data and not convert it, and it's in X, Y, Z values, importing now here directly, as I mentioned. We check the standard deviations and we want to place them around 2 microns for our image points and about 2 centimeters in position and 4 in height as standard deviations. This is now all the necessary input data. We can save the project now. We save it here in the project subfolder in case you want to continue on a different day, so you can load this project for further processing. This is for the project setup now. We can see now in the 3D view when we use the right mouse button how the data looks from different perspective views. So we see our cameras in the air and the control points hopefully underneath of it, or in the classic main view you can see here the footprints projected on our average terrain height. In the next video you will then see how to run the georeferencing. For now, thank you for watching this video tutorial and have a nice day. Goodbye!